Okay, what I want to do right now is I want to move to OSPF, but beforehand I want to cover something that a lot of people are probably asking, and that is what version of DMVPN, I guess, am I running on R2? Well, it's operating as a multi-point GRE configuration, but it's still phase 1 because the spokes are still using regular old-fashioned GRE configuration. The question is, I'm sorry, I misunderstood the question. The question is why did I have issues with the multicast dynamic? And I'll get you a copy of the iOS version that I'm running. It's older with regard to the interconnectivity. I wanted to be able to have the serial connections on our R3, so we're running 2811s in the configs. So with that being said, what I want to do now is I want to rip out EIGRP and put in OSPF because we're going to learn that we have an entirely different range of problems that are going to be introduced by DMVPN. So rather than, I'm not removing any interfaces, all I'm going to do is I'm going to come here under R2 and just take out EIGRP, no router, EIGRP 100. On R4, no router, EIGRP 100. 5, no router, EIGRP 100, and then we'll take it lastly on R6, no router, EIGRP 100. Now, what I want to do here is I want to dive in here and talk about OSPF. Now remember, in frame relay, OSPF was really intelligent. It looked at the frame relay interface and made the determination that I can't use broadcast by default, so it would actually default to a non-broadcast mode. Now in the confines of DMVPN, that's not going to happen. Because in a multi-point GRE, it's going to be picked up completely different. And what I want to do is I want to illustrate that. So what I'll do, first of all, is I'm going to come over here to R2. And what I'm going to specify here is router, OSPF. And what I'm going to do is I want to run everything in area 0. So I'm going to say network 2.2.2, match exactly, area 0. And I'm going to say network 10.10.10.2. match exactly area 0. Do show IP OSPF interface brief, and we're going to see that I have my loopback interface and I have my tunnel interface. But right here's what I want to call your attention to. EIGRP, as intelligent it is, picked this up as a point-to-point connection. Now the moment we start lighting stuff up and turning on OSPF on the other devices, that's going to cause us some problems. Let's look at those. Now we've got our multicast traffic, so we should not have any issues with the passing of our multicast information. Another thing that we could have done in the confines of EIGRP, we could have just went straight to unicast operation if we were told that we could not use multicast for the purposes of exchanging prefixes. Now, in the confines of our current illustration, let's go over here to R5. Actually, no, we'll start on R4. And let's do the marrying config. Router, OSPF, 1. Network, 10.10.10, 4. Match exactly. And I said we were going to run everything in area 0. And I want to advertise my loopback. So it's going to be 4.4.4, area 0. Now notice we formed a tunnel. Let's see, are we actually learning prefixes? Do show IP route OSPF. We're learning prefixes. Do we have reachability? Do ping 2.2.2.2. Let's source it from our own loopback. So 2.2.2, source it from LO0. And we have reachability. So we've checked the fact that the hub R2 can reach our own loopback, and our configuration came up. It's operational, it's stable, and everything is perfect. But we're going to throw that to the wind because what we're going to do is we're going to go down to R5 and we're going to configure OSPF, and then all heck is going to break loose, especially on the hub. So let's take a look at that. So when we go down to R5, router, OSPF 1, network 10.10.10.5, match exactly, area 0, and network 5.5.5, area 0, match exactly. Now what we want to do is go up to the hub on R2, and we're going to see all kinds of complaints and arguments. Notice right here, directly behind me, I'm in exchange. So I went from exchange to down, from exchange to down. Adjacency formed, exchange, down. It's flapping back and forth and back and forth. And what I want to do is I'm going to turn the interfaces off on R5, and then we're going to come back over here and revisit what's happening on R2. So on R5, all I'm going to do is I'm going to come under the interface, tunnel 0, and say shut. Now, everything should do show IP OSPF neighbors. Everything should be hunky-dory and fine, which it is. But what I want to do is I want to say do show IP OSPF interface tunnel 0. And what I'm going to point out here is the fact that, again, it negotiated. OSPF looked at this interface and said, this is a point-to-point interface. Why? Because it's a tunnel. OSPF is not intelligent enough to recognize the fact that this is a multi-point GRE. So what's happening here is because it's point-to-point, it's only expecting to hear information being sent to it from an individual neighbor. By the moment we went up and spun up OSPF on R5, what ended up happening is now I'm receiving information from 2 devices on a point-to-point link, which the veritable definition of a point-to-point link is that I'm only connected to one other endpoint. So this all starts falling apart and becoming problematic. Now, how do we fix this? Well, we fix it by going into the system and configuring it using the IP OSPF network configuration. So what we need to do is we need to pick a mode that's going to allow us to be both point to multi-point and work exactly the way we wanted to have it configured. So in other words, now what I'm going to say, interface tunnel 0, I'm going to say IP OSPF network point to multi-point. Now if I come up here and say do show IP OSPF interface tunnel 0, notice now it's a point to multi-point connection. Now what I'll do is I'll go over to R5 and do the same thing, and then we'll cascade all the way across. Interface tunnel 0 IP OSPF network point to multi-point. R6 router OS, we'll go ahead and just do it the easy way. Interface tunnel 0 IP OSPF network point to multi-point. Router OSPF1 network 6.6.6, match it exactly. Advertise in area 0, and then network 10, 10, 10, 6, match exactly and put it in area 0. And we should get a neighbor relationship post haste. So let's take a look and see what we got going on now. So we've got R4, do show run interface tunnel 0. No, do show run, yeah, interface tunnel 0. Interface tunnel 0. IP OSPF network point to multi-point. Router OSPF1 network 4.4.4, match exactly. I promise we put everything in area 0. And network 10, 10, 10, 4, everything in area 0. All right, let's go back up to the hub and see what we got going on. We should have individual peerings. Adjacencies show IP OSPF neighbors. We've got 4 and 6, but I don't see anything from 5. What's going on 5? No shut. I turned the interface off. That's what's going on 5. There we go. We are full and we're operational. And keep in mind, because the mode of our interface show IP OSPF interface brief, notice because our mode is P2MP, now what we're going to have here is a few things that are going to be happening in the background. We're going to have a situation where our device has become operational with all of its neighbors, but we need to understand what happens in point to multi-point. Now let's take a look at that. So what I'm going to do is on the hub, I'm going to say show IP route OSPF. And what we're going to see here is that everything that I'm learning from my neighbors, I'm learning as a /32. That's going to be one of the inherent characteristics of point to multi-point operation. Now, keep in mind, this should make our network stable. And also bear in mind that this point to multi-point configuration for OSPF is going to serve us well with regard to making certain that we have all of the reachability that we need. I want to verify that, and then what we're going to do is we're going to move into DMVPN phase 2. So let's verify, and then we'll move on. So one moment. So see if we can reach all of these. So 4.4.4 from the hub, 5.5.5 from the hub, and lastly 6.6 from the hub. Now let's go to one of our spokes. We'll go to 4. Ping 4.4.4, no 5.5.5, and 6.6.6. So as you can see, we have all of the reachability, but never lose sight of the fact that if I trace route to say 6.6.6, everything is going to traverse the hub, right? Very, very important, important to look at, and also something I want you guys to keep in mind. So when it comes to OSPF, remember, in phase 1, we want to make certain that we turn split horizon off. It can cause us huge amounts of problems. Inside of the context of phase 1 in OSPF, the preferred method of accomplishing reachability across the spokes and making everything stable is going to be go in and change it to point to multi-point on all of the devices. So when we go in and we look at it from the point of view of phase 2, the rules are going to change, and that's what we're going to do in the next video. I'll see you guys there. Bye-bye.